I'm a hydrogeologist. My motto in life is think out of the box. My name, Marcel. My experience, groundwater and soil contaminations. I'm the creator of Geo RGB, a channel of geographic information systems, GIS, geology, hydrogeology and contamination. The purpose, the objective, the goal, the intention, the target, the desire. Share my experience and acknowledge to create points of discussion. The Geo RGB community. Promote the use of free and open source software. A free digital society. Provide technical advice to environmental companies. An opportunity for professional growth.
Google Earth versus LiDAR, Digital Elevation Model, DEM, and Contour Lines. About this tutorial, this mini course consists in 3 video tutorials. In the first one, you are going to learn how to create a digital elevation model, DEM, with QuantumGIS using data from Google Earth. In the second one, you are going to learn how to use LASTool to process LiDAR data to create a DEM with QuantumGIS. Also, you are going to see how to get the contour lines from both models. The third one, it's going to be a comparison between the 2 models, and we will have a discussion about the accuracy of the ground elevation from Google Earth data. This is the third video, and the topic for today is model comparison, part 3. What you are going to learn in part 3. How to compare 2 models with a visual 3D interpretation. How to create a profile section of the DEM. How to quantify numerically the differences of 2 DEM. How accurate is Google Earth DEM compares with the LiDAR DEM. Google Earth, horizontal and vertical resolution, where the metadata is. Other sources of information to create or download DEMs. DEM, contour shape files, and raster topographic maps created by the government agencies. Comparison between DEM created by the government agency with DEM created with the data from Google Earth. Other topics related to the scale and Google Earth map resolution. What you need to know if you missed part 2 LiDAR. At the previous video, we saw how to download LASTool, set it up on QuantumGIS 3.10 A Coruña, and check the metadata of the file. Also, we saw where to download some LiDAR data and how to analyze it with LASInfo. We visualized the 3D cloud of points with LASView, and we saw some of the options we have to visualize the information. We created 2 different DEM, one with LASToDEM, another one with BLASToDEM. At the end, we extracted the contour lines and we labeled them. Remember that if you missed that video, you can hit the card located at the top right corner of your screen. Today, let's go to start doing a 3D visual comparison between the 2 digital elevation models that we created at the previous videos. Remember that the first model, it was related with Google Earth data elevation, and the second one, it was related with the LiDAR data. Then let's go to load first the models. It's going to be a raster. Click this option here. I have all my files in this folder. First, I'm going to load the digital elevation model related with Google Earth. It was this model. Open, add. The first option is good. And now I'm going to load also the LiDAR data. I have this file here, new folder, and we are going to open the digital elevation model related with LASTool DEM. Open and add and close. Then to make the difference, DEM is related with Google Earth and DEM LiDAR Blast is related with the LiDAR data. Then to see the 3D models, we are going to use this plugin here. Web is this one. And if you don't know how to install this plugin, just check the first video because it was explained in that video. I'm going to leave the link of the video here at the top right corner of your screen. Then first we are going to work with the model related with Google Earth. Then I'm going to check the box and wait till the digital elevation model is loaded. Then first we are going to change some properties here. Left button on your mouse, properties, and I'm going to put this one to the maximum 6 and also here for the resolution maximum for 400%. And apply and OK. And now with your mouse you can move the 3D model. As you can see in this model, the topography is very smooth, right? Also, what we are going to do is change here properties, the color for a solid color, and we are going to add this color, for example. Apply. Okay, as you can see, it's very smooth. Now we are going to work with the LiDAR model. Then I'm going to take this one out and I'm going to add this one and I'm going to make the same changes. Then here properties, resampling level to the maximum, and here for the resolution also to the maximum. And now you are going to see how it changed the resolution, right? Apply. There are a lot of more details now related with the topography. And also we are going to change the solid color for a different color. In this case it's going to be an orange color. Apply. It is obvious that the first difference is related with the detail of the topography. At the LiDAR model, the detail of the topography, it's really good. You can see a lot of different morphologies related with the topography, right? Let's go to close this one. If you compare with the Google Earth model, as you can see here, you cannot see any kind of morphology, right? Even it's hard to recognize the river over here and also over here. But with the LiDAR file, you can see a lot of things. Now let's go to overlap the two models to see the differences. And the first thing that we can see is with the Google Earth model, the bottom of the river is loose, as you can see over here and over here, right? You can see the differences. And also I'm going to say that all the operations at the LiDAR data, it's covered by the Google Earth model. Right, we have a depression over here, we have a depression over here, depression here, depression here, and all depressions are covered by the Google Earth model. Then for the rest, the LiDAR digital elevation model, it's on the top for all these areas. Let's go to take this one now. But this is just a visual comparison, and we cannot see too much about how we can quantify, right, with numbers, the differences. Then in order to see some values related with two models, let's go to use another plugin. This plugin is known as a profile tool. And the plugin is terrain profile. Then if you want to install this plugin, just click here, Remember that you need internet connection. Go here and then write profile. And it's this plugin over here. Just select the plugin, install, and then check the box, and you are going to be ready to use it. And that's what we are going to do now. Go here, terrain profile. Then we are going to create some sections for both digital elevation models to see how the topography is changing in both of them. Then to do that one, just with the left button of your mouse, click any part on the digital elevation model, and then to finish, just double click. And then go here, add a layer, select first here. First we are going to add the profile related with the LiDAR data, then add layer here, and here you can change the color. We are going to add an orange color, okay, and then we are going to select the digital elevation model related with Google Earth, and we're going to do the same, add layer, and in this case the color is going to be a kind of green, this one, okay. And now we can move this one over here, and I can close this one here to have more room, and I'm going to make this one over here and make this one bigger to see better. This one, I cannot make this one smaller, I believe. Oh yeah. And here now we can see some numbers. If you see, when we move over here, there is a point over here that is moving through the line. As you can see when I'm moving. And the orange line is related with LiDAR, and the green line is related with Google Earth data. Here we have the elevation, and here we have the distance. Both units are in meters. The elevation can vary from 534, the minimum, to 645, the maximum. It's a little bit more than 100 meters. And the distance of the profile, it's around 800 meters, even a little bit more. The maximum differences for both models can be found at the bottom of the valley where the river is located. Here we have an elevation of 534 for the LiDAR model, and for the Google model we have 554. Then the differences here, it's 20 meters. 20 meters is a lot if we consider that the maximum differences for the minimum and maximum elevation is 100 meters, and also for the distance of the profile, that it's a little bit more than 800 meters. As we say previously, the differences between both models, it was located where we have a depressions, and the main depression is located here at the main river and also here. But let's go to see a different section, for example one section from here to here, and as you can see here the differences are also big, but not as before. In this case, as you can see, the LiDAR data, it's always at the top, and the Google Earth model, it's below. And as you can see, the topography here, it's with a lot of different kind of peaks, but here for the Google Earth model, it's pretty smooth. Let's go to change to over here to see how it looks like. And here we have, as I said before, we have here a depression, and where we have a depression, the Google Earth model go to the top. But then over here, the LiDAR digital elevation model overlap the Google Earth model. Let's go to see one more section. In this case, it's going to be the connection of the tributary with the main river. Then it's going to be a section from here to here. Sorry, double click here to finish. And as you can see here, we can see big differences, right? Here we have maybe the maximum distance is over here. For the Google Earth model, here the elevation is 561, and here is 542. Again, we have around 20 meters of differences. Over here we have 539, and over here 560, even 21 meters of differences here. And also it's interesting to see how at the LiDAR model we have here the main river, but for the Google Earth model the bottom is over here. Then given these results, the question is the Google Earth data bad data to use? The question is going to be, it depends, right? It depends what is your project, what kind of use you are going to give the Google Earth elevation data, right? For example, if your goal, let me show you one thing. Let's go here, open this one, and let's go to say this one. If your goal, for example, is to delineate the basin of the tributary, maybe you can use Google Earth, right? Because you can see some topography here. Even we can add the contour lines. For example, let me add the contour lines here. Let me close this one here, and I'm going to move this one here to add the contour lines to the top. Sorry. Taking this one out, move this one here. And as you can see here with that one, we can delineate the top part of this valley over here and over here, right? But if we want to calculate what is the volume, right, of the tributary over here, right, all the area related with the basin, maybe it's not going, the Google Earth model, it's not going to be accurate enough, right? Because the model, it's going to provide us wrong information, because as you can see here, we are going to miss all this area over here. We want to calculate the volume of all this area over here. Then there are some limitations, but it doesn't mean that you cannot use the Google Earth data. Other thing that we have to consider is with Google Earth data, we don't have any metadata. The only thing we have is this information over here, right? Let me take this one out and this one out. We have here the elevation, and also if we want to see the scale, let me put this option here. We can see a var scale over here, and that's the metadata we have for this file, right? We don't know where or how the elevation data was taken. If it was with satellite information, if it was with LiDAR information. We don't have that information. Even if you see here the scale bar, let me move where there are some houses. Here you can see these houses and you can see the scale bar, right? But if you go close, the image doesn't change, but the scale is changing, right? But you are not getting better resolution because the resolution all the time is the same. The only thing you are doing is making more zoom, but it doesn't change the resolution of the image. Then that's the main issue for the Google Earth, that you don't have the information where they collected the data. However, when we are using the LiDAR data, we have the metadata and we have the information, what is the horizontal and also the vertical resolution. But with Google Earth, we don't have that information. However, you have to think that in each country, they have an official website where you can download some data related with geographic information system. Each country is going to provide different geospatial data, right? Some countries you are going to get a lot of free products with really good resolution. In another countries you are going to get some products maybe with not really good resolution, and maybe in other countries it's going to be very hard to get something for free, right? And it depends on each country, but you have to know that you have that source, and it's something that you have to consider. What used to be pretty common is a country has a official website where you can download some geospatial data. But also at the same time, the province has their own website where they can also provide different products with sometimes even better resolution. For example, I'm going to compare Spain and Canada. In Spain, for example, you have all the country in LiDAR files for free, but in Canada you don't have that information. That is one example, right? Another example is, for example, in the province of Catalonia in Spain, you can get raster topography maps with a scale 1 divided by 5,000, but in Canada, the topographic map that you can get for free is 1 divided between 50,000, right? Then each country has different products, different things that can offer for free, and other countries can offer that one maybe paying, and also sometimes there are private websites that they can provide you with maps with higher resolution when you pay, right? For example, here in Canada we have this website, Geo Gratis, where you are going to get all the products for free, but also for the province of Alberta in Canada, we have this website, Altalis. This is a partner of Alberta government, and here you have also some geospatial data that you can download for free, but some of the products you have to pay also. Now what I would like to show you, it's here, for example, at the GeoGratis website, we can download different products that they are related with the topography, with the elevation of the terrain. And now I'm going to show you 3 different kind of files that you can download here, but I'm pretty sure that if you make your own search on your country, you are going to find also an official website where you are going to find similar files that you can download for free. The goal is to compare the information we can get from an official website with the information we get with Google Earth elevation data, to see if they are pretty similar or pretty different, right? First, let's go to download a digital elevation model that is already created for the area we are working. Then go here, go to the bottom here, and in this case we are going to select this one, Canadian Digital Elevation Model. And here we are going to go to page 2, and here we are going to download this one, a GeoTIFF file. Access, and the file we are going to download, I'm going to show you here. Let's go to May Zoom. This one is all Canada, and we are going to go to the province of Alberta. It's this area over here. We are going to 83, and we are working in this area over here, Grand Prairie. And this is the area we are working. Then it's 83 letter M, and that's the file I'm going to download. 83 here, and it's going to be the letter M. I downloaded already the file, and it's this one here. I'm going to extract here, and in this case, as you can see, we have the metadata. Then we have here the information related with this file. I'm going to close this one first. And that's the metadata, where we have the horizontal accuracy and we have also the vertical accuracy. And we have the information related with this file. This is the digital elevation model that we are going to load also on QGIS. Then press here, go to Raster, and I'm going to look for that file. Is here, DEM, and is this one. Open and add and close. Okay, is this area over here. As you can see, this file is really big because it's covering all the area, but we are just interested. Go zoom to the layer. Let me put this one here and zoom to the layer. That's the area we are going to cut now from that digital elevation model, because that's the interested area for us. To do that one, I'm going to take this one out, and this one out. And I'm going to bring the working area as a vectorial file. We created this area the other day at the first video. Maybe it's this one area. No, let me see. Shapefile area is this one. Open and add and close. And I'm going to use this area as a mask to cut the DEM. Then go to raster, extraction, click raster by max layer. Here the input is going to be this one. The area is going to be the mask. The source, I don't know what is the source, but it doesn't matter. You don't have to add here, but I'm going to add the target. That is going to be these coordinate reference systems. And that's it. Then run. Close. We can remove this one. Okay. We can take also the area. We don't need it. Then remove this layer also. Okay. And is this one, but it's a temporary file. Then we are going to save, and then export, save as. Let's go to add a name here. It's going to be the same this one, but I'm going to add clip at the beginning. Clip and save, and the rest of the parameters is okay and okay. And now we can remove this one. Okay, and this one is the one we created. Oh, sorry, I make a mistake. Okay, but it's safe. I have to remove this one and keep the other one. Remove this one, okay. And I'm going to add the one we save. This one. Go here. Here, Geo DEM. And it's this one. Open and add and close. Now we have three models. We have this one is the one we downloaded from the official website of the Government of Canada for the digital elevation model. We have this one. This one is from Google Earth that we created at the first video. And we have also this one. That's the LiDAR data. And that's the model we created at the second video. Now what I would like to show you is the comparison between this one and this one, to see how different or similar they are. To do that one, we are going to do the same as we did previously, but first I'm going to close these windows. I'm going to open a new one. This one, and okay, I want this one. I'm going to leave the same color, and also I want this one, but I'm going to change the properties here for the maximum resampling and also maximum resolution and a solid color of gray. Apply, and that's what we get. As you can see, these two models I'm going to advance. They are pretty similar. As you can see, there are not too much differences. Okay, and if I take this one, you can see the differences are not too much. This digital elevation model, the one we downloaded from the government, has these squares that it's not really nice, but that's what it gets for free, right? And that's, I believe, the problem. It makes this kind of pattern, right? Now let's go to see the profile. I'm going to close this one. And let's go to open the plugin. It was this one, terrain profile. I'm going to add this one over here. Okay, something like that. And I'm going to make this one bigger, and I'm going to add one line from here to here. Double click to close. And okay, I'm going to change this line here, from here to here, double click, and I'm going to add first this one. We said that that one is a kind of gray. Let's go to put this one here, for example, okay? And let's go to add this one. And this one is going to be, sorry, green line. This one here, okay? And as you can see, the models are pretty similar, right? At least for this section. Let's go to change the section from this one to this one. And again, well, you know, the digital elevation model from the government, it has some peaks over here, as you can see. And for the Google Earth model, it's like the average of the Lila line, right? Looks like the average. Okay, let's go to change the section. Now let's go over here as we did previously. Here maybe there are more differences. Here, for example, the maximum differences for the elevation. Here we have 596 and here we have 598. This is 2 meters of differences, right? And here we have 92 and here we have 90, again 2 meters. Let's see what happened over here. Again, they are pretty similar. And in this case, we have the metadata, right, for this file. And we was thinking previously maybe that the Google Earth data, it was not really good. But now if you compare with the digital elevation model from the government, where we have some metadata, both models are pretty similar, right? And now maybe we are feeling more confident using elevation data from Google Earth. From my point of view, this digital elevation model, the one from the government, looks like a digital elevation model that can be created with contour lines for a scale of 1 divided between 50,000, right? Because, you know, I created the digital elevation model. As I said previously, here we have 3 different options. We can have the option to download the digital elevation model, but also if we go to this option here at the Geo Gratis, we have also this section over here, download maps and data. And here we can get the raster maps and also vector data. And if you go to vector data, you can get the topographic data of Canada. And here you have the shape file for contour lines of scale 1/50,000. Where is that one? Go back. Let me check one thing. Go back. Elevation in Canada, sorry. Is this one here? Then you can download this one, that's for shapefile. 50K for Alberta. Okay, I downloaded this one and I get the file. Is this file here? Go back. Vector, this one is this file. And here you have the contour lines for 50K for all the province of Alberta. And with that shape file with the contour lines, you also can create a digital elevation model. I have a video tutorial if you want to do that one. I'm going to show you now. This is my YouTube video channel. And here you have a couple of video tutorials. Is this one and this one, lesson 7 and lesson 7 extension, where I created the digital elevation model with that contour lines. And then I compared the two digital elevation models. One it was created with the contour lines, and the other one was the one downloaded directly from the government. I'm going to leave here a card at the top right corner of your screen. If you hit that card, you can get access to that video tutorials. And what I saw in that tutorial is the digital elevation model provided for the government. It was pretty similar at the digital elevation model that you can create with contour lines 50K. And that's the reason because I believe this digital elevation model, this one, the one we downloaded from the government, it's for around 50K. Then with that conclusion, and in this case, we can say that the digital elevation model from Google Earth, it's very close to a resolution of 50K. But one very important thing that you have to know, it's Google Earth not always has the same resolution for all the areas. The resolution is changing a lot, not just for the horizontal, also for the vertical, I believe. Sometimes you can get a very high resolution panchromatic images where you can see houses, people, and everything very well, but in other areas the resolution is not that good. Then the resolution is changing, and you have to consider that one. Even I said for this map that I believe the elevation has a resolution of around 50K. It doesn't mean in other areas it's going to be the same. You have to be aware of that consideration. Also, other important thing, it's not the same, for example, when you are working in an area where the ground is totally flat, like here. For example, let me take this one, and you can see now the elevation of, if you check here at the bottom for the elevation, if you are moving over here, it's not changing at all, right? Maybe 1 meter. That indicates that this area is really flat, right? And if you have an area like that one, maybe it's easy to work with Google Earth data because it's not going to be a lot of wrong elevations, right? But if your area has a lot of topography, it is going to be more complex, and maybe you have to look for a better source of information. Now the last thing I would like to show you is the last source, and in this case, let me go here, Toporama, and in this case is going to be the raster files. That is the third option. If you go to raster files, you can go here to this option, digital topographic raster maps, and here you can go to GeoTIFF, GeoTIFF 150,000 for the scale, access. Then as we said before, it was 83 and it was the letter M. And here even you can check for the numbers. Let me show you. The area we are interested, it's 83, letter M, and in this case is number 2, is this area over here. That's the number I want to download. And then you can select the first option. I did already, and I'm going to show you now the map. GeoGratis raster is this image. That's a hard copy of a raster topographic map. and the area we are working is this area over here. But here you have to check all the scales and all the information related with this map, because the elevation here is in feet. The advantage of using a map like this one is that the map is already geo-referenced, and you can load here. Let me close this one, and I'm going to load the raster map here. GeoGratis, raster, and this one, open and add and close, and let me move this one to the bottom. And as you can see, it matches perfectly with our area, right? It is interesting to know that even you can use this map to create a digital elevation model, because you can copy all these contour lines, digitalize the lines, and then with that lines assign a elevation, and with that lines with the elevation you can create your digital elevation model. Then you have a lot of different ways to create digital elevation models with different source of information. Well, this is the end of this video. Thank you very much for watching. Hopefully it can help you to understand a little bit better the use of Google Earth data elevation, and see you on the next one.